There we go. Is that better? Perfect. All right, so my name is Brian Voice. I'm the Economic Sustainability Manager for the town of Berthoud. It's a little confusing, economic and dark sky don't seem to really go together. I used to be the assistant to the town administrator working on this sustainability action. So today we're gonna highlight the progress that we are doing towards this certification. This certification is an internationally recognized honor for communities that actively preserve their night skies, protecting our dark skies through responsible lighting, public education, and smart policies. I'll just quickly go over, there's, I believe, 6 categories for certifications that you can earn. Parks, reserves, places, communities, lodges, and then there's one other that I could not think of. But as far as communities in Colorado, there are about 6, I want to say. None are located along the Front Range. So Berthoud would be the first along the Front Range to do this. It seems to be a little bit harder the bigger the community, because the bigger the community, typically the more light pollution. So it is a little bit harder for them to reverse all the light pollution. A little bit louder, okay. I'll just keep going here. I would also like to thank our steering committee members that have attended. So if you would like to just give a quick wave. They volunteer their time as well. So I'm just gonna run over some of the steps that we have to do to earn this certification. Our first big step has been to establish a sky brightness measurement program. So what we do with this is we have the meters placed around town. They are continuous readers. I should have brought one with me, but they essentially, in rough terms, they look like a pipe bomb. Yeah, it is.
Not really.
Yes, yeah. The sheriff's office does have photos of them, so if you see one, do not call it in. They know that they exist. It is just a PVC pipe with essentially a meter about this big, a little bit bigger, in there with a solar panel, and then they just charge themselves. And then once they hit a certain darkness, they start taking readings. And then every so often, whenever I remember to go out and check them, we get the readings and then we send those into dark sky. And we have 3 of them placed right now. I have 5. You typically won't see them. There's one at the cemetery, one on top of Town Hall, and then one at Berthoud Reservoir on the east cell. So where the non-walking trail is, it is on that side. But we'll get more throughout town just to keep making sure that we are making progress as far as not getting brighter. We either want to maintain our brightness or ideally get darker, which we will do through with some of these next few steps. Community engagement is also key. Our outreach plan is to involve experts, which is why we are here today. Schools, we have partnered with some of the STEM students. They are helping us do one of our next 2 steps. They are doing a light inventory with Pat, one of our volunteers as well. And then just working with the businesses. We have the chamber president here as well, who is also one of our volunteers. And then nonprofits. So another nonprofit that we partner with is the Historical Society. To put a quick little plug in, they do star nights as well. They have a telescope, I think 1913. Do you know?
Something
Mine's about that old. It is. Yeah. And one of the
first Friday of every summer month.
There we go. Thank you. So we partner with all these great groups, and then we either host or partner with at least 2 public education events every year to inspire the stewardship of our night skies. So we previously held, we had a guest speaker at the library, was that about a month or 2 ago? A professor from CU who came and spoke about the importance of dark skies and animals, how it affects them, and insects and everything like that. So next, one of our main priorities is our lighting management plan. So this sounds simple. We just need to review our lighting ordinance and all of our policies that we enact for residents, businesses, and ourselves. And then we need to update them to reflect what dark sky requires to keep the lighting as responsible as possible, and then keep our natural night skies. And then, as I mentioned, we have a lighting inventory that we have to do. So every town-owned light or leased, we have to go out and check and then do a reading for each one. We have to put in all the information about that light. So every street light, every building that the town owns, we have to go check every single one of those lights. During the day is the easiest, and then we also have to go back at night to do a reading. So that is where our steering committee comes in handy, and then our STEM students that are also going out and doing these readings for us. It is very important because as we update our town code, we have to update all of our lighting and come into compliance with that. So that is a huge step for us. And then, so once we do all of this, we put our application together. It gets reviewed multiple times. And then hopefully when we get certified, we're not done there. So each year afterwards, we have to continue doing our readings to make sure that we are not getting brighter. We have to continue hosting events, and then we have to create a yearly report and then send that off to Dark Sky to make sure that we are keeping our progress and then setting up the future generations for success as well. And then, so with these steps, we will demonstrate that Berthoud honors tradition, embraces stewardship, and looks to a brighter, darker future together. So I'd like to thank you.
Thank you, Andrea. Thank you, everyone. I feel bad I was hogging the microphone. But hopefully you can hear me in the back, no problem? All right.
Do we need more chairs for people in the back or not? Or are you okay standing? Fine.
Because we have more chairs. They're all here in the front. We can put them in the back. So I don't mind waiting a moment. I'll take a sip of coffee while you...
Set up a couple chairs up in front here.
We want you to be comfortable. So yeah, please pull out a few more chairs. Let's everyone get comfortable. Let me make sure that this will actually advance slides. Happy solstice. And while we are waiting for chairs to be set out, let me remind you that I need help of some younger people, especially if you've got a phone or a watch. We need to pay attention to 8:42 p.m. 8:42 p.m. because that is the exact time of solstice. So, do you have something to pay attention to time with? All right, very good. When it is 8:42, I will forget because I'm going to be busy talking about other stuff. So I need you to keep me honest, okay? You gotta, don't just raise your hand and be polite. Shout out, it's 8:42, it's solstice. All right. Well, it certainly is warm enough today, do you think? Did you sweat enough today? Okay. So I have a little activity I'd like everyone to do. And only if you're comfortable doing this. If you don't want to and you want to stay seated, feel free. But if you do want to stand up, I'm going to teach you a little something. This is going to be a little hard to do for me because I don't have pockets. But come on in, have a seat. We've got more seats up front. This is excellent. So we're going to pretend that the projector up here is the star Polaris. Why do we care about the star Polaris? North, that's right. And Ginny, what are you going to say?
Well, so is that technically the stars of the day?
You might be confusing that with something else. I think Polaris is just one star. Is that correct? You may be thinking of the Centauri system, which has Alpha, Beta, and Proxima Centauri, which is the star closest to us, but that's not Polaris. So that's okay. Good conversation, though. And we will talk more later. But so yeah, we need to pretend that that's the North Star. So we're gonna put our hands together, sort of like in a praying position, And that's going to be, come on, stand up, everyone. It's much easier if you can. If you cannot stand up, that's okay. If you don't want to, that's okay. But if you do want to, so that's north. And of course, Earth is tilted on our spin axis. How far is Earth tilted? That's right, 23.5 degrees. So if you can, tilt 23.5 degrees. And then I would like you to rotate. You have to spin, oh wait, but you have to actually keep your North Pole pointed at Polaris. Yeah, okay, everyone sit down. We're gonna have our young, spry people come up. Anyone under age 15? We're not done with this demo. Anyone under age 15 who wants to come up, please do, because we need a little bit more help. And your name is?
Corinne.
Karen, would you please grab that yellow light bulb? Oh, come on. We need Sadie. We need a few other people to come on up. Come on up, because you're going to be planets, asteroids, comets, anything that orbits the sun. And Karen, you're going to be the sun because you're tall. You're taller than I am, I think. Come on, let's do back to back. Is Karen taller than me? Yeah. Thank you. So, Karen, can you step 2 steps forward? And all the rest of you, make a circle around Karen. I'm going to stand back here. I'm coordinating you guys. Make a circle around. Thank you. Karen, you got a Statue of Liberty with that light bulb because you are the sun. All right, so everyone else, assume the position. This is your North Pole. Remember, your South Pole is your hind area. And so Polaris is the North Star. You've got to tilt, you got to rotate. Let's practice that. Tilt and spin around your spin axis. Thank you. Now, while you're doing that, please go around the sun. Because this is what planets, all right.
Probably, was one of the kids saying that Polaris is a double star?
Yeah.
Yeah, they were right.
Oh, excellent. All right, thank you very much. I don't want anyone getting ill. Karen, put the light bulb back. Everyone else have a seat. Thank you very much. And Ginny, Mark just told me that your discussion about Polaris is correct. It is a double star. I was wrong. You were right. Let's hear it for Ginny. So Ginny was right. It is. Why don't you talk about it, Mark, since clearly I don't know about Polaris.
It communicates everything. According to Google, Polaris is part of a triple star. So, yeah.
And if we were in class, you would not only get a gold star, but you'd get a little note, and you'd probably then get a note from the principal going, "Good job."
We need the bookmark again for us.
All right, that's a nice prize. So, all right. As you have just discovered, any object that orbits the sun has to do that complicated motion. So the whole spin around yourself, that's a rotation. That's a day-night cycle. But of course, objects like planets and dwarf planets, asteroids and comets have to go around the sun. And as that happens and they maintain their axial tilt, meaning they keep, if you're Earth, that 23.5 degree tilt, but if you're a different planet, you have a different tilt. Everybody's different. Which planet is sort of lying on its back? Uranus, very good. That's got a 98 degree tilt. So yes, it can get very complicated, and seasons on Uranus are completely different than seasons on Earth in terms of how long they are. But the whole concept of having seasons, Uranus has seasons, they just last several years. So every planet has seasons, every dwarf planet, etc. And what makes today so special, if I can get the laser pointer working. Joe, you took the dongle out. I'm not sure it works. Oh, I did turn it on. Let me turn it on again. Yep, there, now it's on. Thank you. Yep, I was able to advance the slide, so this works. Okay, so we normally think that it's hot near the equator because that's where all the direct sun rays go. But today at 8:42 p.m., keep an eye out, the direct rays of the sun are going to hit the Tropic of Cancer, which is 23.5 degrees north of the equator. Because we're in the northern hemisphere. And that 23.5 degrees north of the equator, that's our tilt. So it really all fits together. Then, of course, as we go toward fall equinox, and it will maybe cool off by late September, I'm not so sure. Then the direct rays of the sun will hit the equator. Then for winter solstice, it will hit the Tropic of Capricorn, go back toward the equator for spring equinox, and back and forth and back and forth. It never goes further north than that for the most direct rays. But obviously we have sunshine during the winter. It's just that the sun's rays are coming in at an angle instead of being direct. Any comments or questions about that? Yeah. Why is there a tilt is a really interesting question. And why do different planets have different tilts? It's also a really interesting question. It is a matter of supposition right now. I'm not going to say theory, but people are thinking that when Earth was pretty young, we know there was an impact with a Mars-sized object, and that helped give us our moon, our wonderful lopsided moon. It could be that impacts like that, not necessarily that one, but impacts like that hit Earth, and this is the tilt we ended up with after all of those punches. So that's one idea. Because think of it, when you spin a top, right? I don't know how many of you play with tops, but if you spin one, the faster it goes, the more vertical it stays. It's only when it starts to lose energy and it starts to wobble that it starts to tilt. So those dynamics are involved there as well. It could very well be that Earth's axial tilt will change over time, but we've been fairly stable at 23.5 for a while. So it's going to take a whole lot longer than a few billion years for us to change our angle because of that wobble. That's a whole nother talk. Thank you. Maybe next June. Does anyone else have an answer or a question? Yeah.
So how is the axial tilt measured? What's the reference point?
Well, that's a good question. I mean, we do have geographic north. That's, how do we, I'm going to leave that to you, Marta. Do you know?
Put a stick in the ground and see. Isn't the reference point the plane of the orbit?
Yes. Thank you. Thank you, Mark. Andrea, do you want to add?
And also how far north you can do at the solstice and have a stick in the ground and have it be straight down at noon on the stick.
If my memory serves, that was the ancient Greek astronomer Eratosthenes who did that. Thank you. Anything else, George? No?
I'm just confirming that he knew that the sun was vertical in Alexandria.
Okay.
So,
It was summer solstice.
So he then measured what the angle was in Greece and deduced the circumference of the Earth.
And he got within about 2%.
Yeah.
And nowadays we still have people who think it's flat.
And I suspect there were people who were playing with sticks and shadows in Africa, in North America or South America. You know, we tend to think of astronomy as being ancient Greek, but it was also in ancient India, ancient China, ancient wherever you can think of. There were people, there were really curious and smart kids who were figuring all of this out. And some of them, even as grown-ups, admitted that they learned something from that. So, anything else before we talk about telescopes? Yeah. Capricorn and Cancer. That is a good question. How did we get these zodiacal names? Anybody?
Signs of the zodiac and time of the year.
But where did the name Cancer and Capricorn, where did those stories come from? Ginny?
Greek mythology?
Yes, Greek mythology. Remember, as Andrea and George were saying, we've got Eratosthenes and other people playing with this, so they were drawing on their own stories, and those stories got embedded into our language. Scientific language is language. It's made up by people. So you can actually learn an awful lot by looking at the word and figuring out, are those ancient Greek prefixes or ancient Latin? Or do they come from Arabic? In astronomy, haven't you noticed there are a lot of stars that start with Al, A-L? Yeah, that's Arabic. So you can get an awful lot of human cultural knowledge just by learning the language that that's come from, looking at the context of the person who is doing the work. It's a whole study in itself, and maybe that's what I'll talk about next year. I don't know. Let's move on. Please.
In other cultures, the signs of the zodiac have different names, of course.
That is correct.
So, my understanding is that people are looking at the stars and said, oh look, that looks like a crab. See, here. Oh, that one looks like a big cross. And so they call that in their language.
Yeah, thank you. That's a really good call out, because if you look here at the star wall, where we have the Lakota constellations, these are different names. We're talking about the Road of the Spirits, not the Milky Way, and all sorts of other interesting cultural insights. Come on in, have a seat. We've got some seats up front. I think there are some other seats in these other rows that are available. And what we're going to do tonight is we're going to take, and feel free to cut me off if I go too long. I don't mind if you guys interrupt me. We're going to look at what. Can we dim the lights, maybe?
Been waiting for it to get dark, so keep going.
Keep going. This could take a while. And remember, what time are we looking for the actual moment? All right. So we're going to take a tour of some amazing remote telescopes around the world. We're going to talk about how we can protect, or maybe not protect, not only the telescopes, but the dark skies above them. And then we're gonna talk about, what we can do. So let me start with a little bit of local history. I don't know if anybody remembers, there was a telescope on what used to be called Mount Evans, now it's called Mount Blue Sky, called the Meyer-Womble Observatory, run by the University of Denver. Bob Stencil was the person in charge. Minta, you're nodding? I may need some of your institutional memory, because honestly, I did not ever go there. And it was in a fantastic location, but there were incredibly strong winds. And one year, I think it was 2012 or 2013, the winds just got too strong and there was too much damage, and they had to decommission the whole thing. And they took down the 28-inch telescopes, and I think they're still at DU somewhere, although I'm not sure. Do you know where they went?
Read another contract to build another dome, but the contractor had never built a dome, and instead of a circular dome, it became an oval.
Oh no.
Didn't work so well. They finally sold it for scrap metal. The telescopes are, I'm not sure where they went.
Okay.
They went down to Denver. They may be in storage. It's a dual 28-inch.
Yeah, thank you. That's the thing. It's the telescopes that are valuable, but the building that makes it available to the public. So I'm going to make the pitch now. If you have an opportunity later tonight, go up the stairs in the back and take a look through the scopes. The solar filter is still on. There's a radio telescope this way, and this is also another dome. Yes?
Yep.
Yes. So Minta and Andrea and the other volunteers will let you know what to do. But this what you're sitting in is an amazing facility, and you should absolutely enjoy it. Well, one of the reasons why Meyer-Womble was not rebuilt was the light pollution coming in from Denver. So if you can see in this bottom photograph, Mike Danson says, this yellow sea of light pollution. Look at that. And this was 12 years ago. Can you imagine how much more light pollution there is from Denver now? And even out toward the airport. Has anyone been toward the airport recently? There's a lot of building. Minta?
It's a new astronomical feature. We call it the Denver Nebula.
Anyone else have memories from Meyer-Womble that you want to share? Yeah.
It was at 14,000 feet. It was so high. And the early days, the observers would, the range would work quite right. And they would find that they would need to take a break and come down to the lower elevation. Then they'd remember what they were supposed to do to go back up. I suppose later on they fit the lock. In the early days, they had a process of the lock.
I believe that, actually, because one of the telescopes I'm going to tell you about later has that exact same problem. So one thing that I was hoping Brian would mention, I'm glad you didn't because now I get to talk about it, is the Bortle scale of light pollution. Let me tell you, I grew up in Buffalo, New York, which is Western New York, and this was my sky. In fact, when I was a kid, your age, I thought the sky was supposed to be purple. That's the normal color of the night sky. I was in college before I saw stars, real stars. And I was on a field trip. In those days, I was doing choral singing, and we were out at some remote place in Maryland. And all I could think of is that Isaac Asimov story, Nightfall. If you've never read it, people go crazy at the sight of the actual night sky with stars. I didn't go crazy, but that was also the first night I went to a bar. I was underage. Whoops, went a little too far, sorry. Got too excited. So, kids, do your stargazing now and stay out of the bars. But I looked up Berthoud, and Berthoud is actually a number 5. Okay? So there is opportunity to get down to a 4. That would be awesome. You would see so much more. And as Andrea and the wonderful volunteers pointed out, you will save money because you're not wasting light. You're directing the light exactly where you want it to be. The light is more efficient. Yes?
Where does Denver fall?
Oh gosh, Denver. Denver's like a 7 or an 8, depending on which neighborhood you're in. Yeah. But the point is, we not only know we can do better, we're tracking it. There are light pollution maps that are publicly available. This one's really interesting. It's just lightpollutionmap.info, because you can put in your latitude, longitude coordinates, and it will just pop up with all sorts of things, including the Bortle classification. Okay, so I like that one. But Andrea, you got your PhD at the University of Wisconsin at Madison.
I did.
Did you ever work with David Lorenz?
No, he came after me, but they are doing great work.
They are doing great work. So this is David Lorenz's own light pollution atlas site. He's got all sorts of stuff. He also works with OpenStreetMap. You can spend a lot of time playing on that map. So we're not going to do that tonight. I'm just saying it's available. And thanks to Joe, the recording of this will be on the starkids.org website. So you can always come back to this. And I do want to give you the PowerPoint. So these are live links. If you have the PowerPoint, you can just click on the link and it will take you right to the light pollution map. That's great. Any comments or questions before I move on? Okay, so let's look at where the new telescopes are being built. Let me give you a hint. At elevation. Get above everything. And probably no one is on a greater telescope building binge right now than China. They have, for the past few years, been building quite a number of scopes in the area called Tibet, but also in the neighboring area that I can't pronounce, that I'm not going to try to pronounce. Not the Uyghur area here, but sort of where Tibet curves over here. Lots of telescopes in this area. There are mountains all through here because, of course, these are the Himalayas. So lots of high mountains and high plateaus. There's also stuff in Inner Mongolia. This is the country of Mongolia. And if it's between Mongolia and Beijing, that's called Inner Mongolia. Well, Beijing makes Denver's light pollution look like nothing. So you got to get really far away from Beijing. So on this side of Mongolia and over here, this is where most of the telescopes are being built. But pay attention to this geography, because we're going to talk about India, we're going to talk about Iran, we're going to talk about other places. I just want to point out that they are serious about their telescopes. And this particular one is in the Tibet region. And I wish it was a little darker, you'd be able to see the gorgeous night sky. But here's the thing I really wanted to point out, and for those who were too far away to read this, let me do it. An environmental protection regulation will be put into force. This was from a 2022 article. This has since come to pass. Let's put out some more chairs in front. Let's put out some more chairs while I'm reading. Thank you. So an environmental regulation will be put into force in Haishi, Mongol, and Tibetan Autonomous Prefecture for better observing conditions. Both types and brightness of light sources must be put under strict control. In Berthoud, it's optional. It's not optional in China. If you're under this, they're telling you that the direction of all fixed outdoor illumination should be tilted 30 degrees toward the ground, and in the buffer zone should be horizontal. And as one of the people they interviewed said, we will do our best to protect these big guys. And by big guys, they mean these telescopes. So scientists can see what they want to see. So they are serious about this. There are 9 different mega telescope projects in Tibet alone, plus the other ones I mentioned. There's value to China in astronomy. Think about that. Why are they focusing on this? What is the benefit? And if they are seeing benefit, we know there's benefit. We can benefit ourselves, right? Astronomy teaches you stuff. So let's take a look at one of the telescopes that's under construction. This is what it looks like right now. It's just a big circle, but you can see from the size of this building how big this thing is. 14.5 meters in diameter. And this is, because we should be obvious with our naming, called the Large Optical Telescope, but it's going to be 4 times bigger than the biggest optical telescope we have in the United States, the Keck telescope.
140 meters instead of 14.
Yeah, it's pretty big, yeah. I think so. So the National Astronomical Observatories of China is racing. They're racing to have this running as early as 2030. What year are we in right now? So 5 years they want this fully done. And it's at Saishiteng Mountain at 4,500 meters. Okay, so multiply that by 3. 14,000 feet. East of this town in this province that has exceptionally dry and stable air and is far from artificial lights. They are taking their dark skies seriously. Comments?
But wouldn't it be more beneficial to have a telescope that was stronger in a little building?
I think they want the capabilities of a large optical, and because there are different kinds of telescopes. And thank you, I should have put in a slide about the electromagnetic spectrum, and I did not. Optical is right in the middle, but if we go to the longer and longer wavelengths, there's microwave and radio. If we start with optical in the middle, and we go in the other direction to the short wavelengths. Then we get ultraviolet and I'm blanking. Oh, and X-ray and gamma ray. And all of those telescopes give us useful information. So depending on what we're looking for, we want a different kind of telescope in a different kind of building, or we want it put in space, in orbit around Earth, or maybe in orbit around the sun. James Webb Space Telescope, is that near Earth? No, it's at what's called an L1 point, and that would need a whole nother discussion. Yeah.
So the use of this, you get more mileage out of something on Earth at a high elevation, that's an example, versus the web, because there's limited finite resources. You can use this as much as the web, I suppose, so many hours in a day.
Yeah, but you're looking at different things, and you're looking in different ranges. And for those of you who like to put your eyes on actual scopes and get photons hitting your eye, what's the benefit of an optical telescope?
Same as what see your results.
You see your results, but you also get different results that you can then compare to the other wavelengths. There is value, and we'll talk about that in a minute.
Suzanne?
Yeah.
In telescopes, like some other fields, size matters. The bigger your size is, the more light you can gather. What are you going to do with it? Right? And so size really is important, and that's why they build it as you compute still like that.
Sure.
That's one. Size matters.
Yeah, so the light bucket is what you're referring to. The bigger the bucket, the more you catch, the more you can do with. What do you want to look at? One forward.
So this is typically called a sparse aperture telescope. So if you don't fill in the middle part of the mirror, if you will, and just look at the outside edge, you get high frequency information. The middle part gives you color and nuances. The outside edge gives you high frequency tick bars, basically. You can have a 1 kilometer, 2 kilometer, 3 kilometer sparse aperture telescope that acts like a regular telescope. It just doesn't have the smooth colors from the middle, the low frequency information.
So you save money because you don't need a lens or a mirror. This is cheaper.
These 12-inch telescopes all the way around that are all focused at the same point.
That's really clever. Thank you. Anyone else? Okay, so obviously China, being that serious, wanted the darkest skies on the planet. They went to Australia about 10 years ago and said, hey, can we share your Australian space in Antarctica? And the Australians were like, sure. Because as any of the volunteers here at LTO can tell you, you want dry air, you want cold air, and you want stable air. You don't want any jiggles of atmospheric molecules. You don't want the oxygen jiggling around all excited. You want to keep it all calm so that you can get the clearest image you possibly can if you're looking optically. But it's also good for infrared, because infrared, have you ever cooked something on a stovetop and the burner gets red hot, and then you take your kettle or whatever off the hot burner? Don't put your hand on it. But if you hover your hand over where the burner was red hot, it's not red anymore, you'll still feel heat. That is infrared. Infrared is heat. So we can maybe not see through dust with our eyes, but we can see through the dust with an infrared telescope. And if you have it in a really cold place where the air is really still and calm, that is a terrific location. There was also, you were just talking about how you're going to have a remote telescope, Mark. The Plato telescope has been in Antarctica for a few years. And it's really hard to do maintenance on it because it can get as cold as 80 degrees below 0 Celsius. That's really cold. But the cold helps counteract interference. And this way you can look at other things that are cold, like asteroids, young stars, and interstellar gas. So let's stay on Australia. We've left China. We segue to Australia. Australia and South Africa are doing what Minta said. Let's have some telescopes that are far away from each other and have them all focus on the same sort of thing. So they're making an observatory on 2 different continents, South Africa and Australia. And if you put all that land space together, it's a square kilometer, which is like 1 million square kilometers. When you think a million meters, that's what I'm trying to say. 1 square kilometer is 1 million meters. Australia and South Africa. So, what was that? 8:42. Is it 8:42? No, okay. All right, we're good. So, the Square Kilometer Array is an international effort to build the world's largest radio telescope. Why do we want radio? What does radio tell us?
It can be cloudy.
It can be very cloudy. This is why you've got a radio telescope out here. You can still look at meteor strikes, and you can look at all sorts of interesting things. You can also look at stars that are really far away or really, really old. Sometimes that's the same thing. Old and far away are synonymous. In the radio, you get what's called red shift. And the more red shifted something is, the more likely it is to only be visible to a radio telescope. So this is where we look at the really old stuff from the beginning of our universe. So by deploying thousands of radio telescopes, it will enable astronomers to monitor the sky and survey thousands of times faster than any system currently in existence. This is under construction. It does not exist yet, but they're investing in it. You know who else is really investing? India. You know how India has been sending spacecraft to the moon and Mars and various other places? They've also been investing in astronomy on Earth. And they've got several big observatories. I'm not going to try to list them all because I can't pronounce them. But there is the 30-meter telescope that, again, is under construction, this time in Hawaii. And have you heard of the telescopes in Mauna Kea, Hawaii? Yeah. And again, at elevation, you get above the clouds. You also get where the air is cold and still. You're seeing a lot of these themes repeat. Well, they also, oh, go ahead.
Is there a scientific, in the scientific community, is there a core international sharing of information, like, you know, public domain NASA discoveries?
Yeah, IAAA, what is it? IAU, the International Astronomical Union, and what's the other one? There's American Astronomical Association and AGU, American Geophysical Union. They do a lot of astronomy stuff. Geophysics can extend through the atmosphere and into orbit. So there's a lot. What India has done is, just like China, they've created a whole chunk of territory called the Hanle Dark Sky Reserve. And because they've got the dark skies, and you know how congested India is, India makes China look like it has no light pollution. So remember, we started with Denver's, that yellow puddle, then we went to Beijing, and if you go to New Delhi, it's, you know, purple, it's lavender skies, not even purple skies. So if they have a dark area, it says due to its superior sky conditions, this region of roughly 22 kilometers radius has a wildlife reserve. And now it's a dark sky reserve, the first in India. And there's a memorandum of understanding through a bunch of groups. They're making a big deal. Makes what you're doing in Berthoud look small, but also awesome, because you're part of an international effort to recognize how important these dark skies are. And I'm just going to keep coming back to this theme. There's value. Why would countries like India do this? There's value. So here's my controversial slide, and where I'm going to go slightly dark in a different way. This is about Iran. And Iran is not known for its dedication to science, and yet the scientific community in Iran has been strong and consistent. People were smuggling in telescopes. Do you remember, Andrea, you had your own little make your own telescope project, a lot of people were buying those and smuggling them in so that they could have star parties. And women and girls could learn astronomy. It has to be done quietly and in someone's backyard, but you can still do it. So when they decided they were going to have their own telescope, they had to smuggle in equipment because there are economic sanctions, which means you're not allowed to just go buy a lens or a mirror or, you know, whatever you need for your telescope. Just trying to get the parts, trying to repair it is challenging. Well, right now, Iran's at war, and I don't know if those telescopes are going to survive. So let's move on to Mexico. Remember I said you've got radio on one side? Well, this is a gamma ray observatory at the base. Here's the gamma ray observatory in the base of an active volcano. Why would you put it at the base of an active volcano? Because those are some of the best seeing conditions in Mexico. Again, cluttered. There are so many people who live in Mexico City and the environs that it's hard to find a good spot. Well, gamma ray is completely different than optical or microwave. For this, you need, I think there are 300 grain silos filled with water, and they're trying to catch gamma rays. So this is called the High Altitude Water Cherenkov Observatory. This is a gamma ray detector. Yes, what is your question? Yeah, we're good. What is it?
So, what are the legends of space?
What are the legends of space? That is a good question. There are a lot of them, and we'll talk about that in a little bit. You okay if you wait for a minute? Thank you. So this place is affiliated with Los Alamos National Laboratory, Los Alamos in the United States. And they're looking at ultra high energy gamma rays and looking at the galactic center of our own galaxy. What's our own galaxy called? Exactly right. So here's the problem in Mexico. They've been having some financial difficulties, and they have a different telescope called the Large Millimeter Telescope. That's kind of, well, it ran out of money last year. And the question is, could they get that funding? Could they crowdsource it? Well, not easily. And here are the other concerns. Over the past 6 months, and the adults will know what I'm referring to, we've had a real loss or redirection of funds for federal research, and that includes international partnerships. And the United States is involved in a lot of international partnerships. So if the United States says we want to spend our money on different things, bye, that leaves a lot of them in the lurch. There are also barriers to free movement. Come on in, we will put out more chairs. If we can get a volunteer to put a few more chairs in the front, please. Thank you. So if people are not allowed to go to conferences, if people are not allowed to share information with each other online, it's hard to do astronomy, because astronomy these days is, thank you very much, astronomy these days is very international and has for hundreds of years been very collaborative. You don't do astronomy by yourself, you do it with a team of people. Have you ever seen one of the scientific papers of a research team? It's like hundreds of names. This is why it's somebody et al., because the et al. Are the hundreds of people who worked on that project with them in many different places, including many different countries. So it's really hard to do astronomy if there isn't enough money or there aren't the right people in the right places. And of course, that means research priorities may shift. So there's war, there are economic challenges, there are technical challenges. And then we come to South America, which is where we're going to spend some time, but I need a time check. Can somebody check the time? Okay, thank you. All right, so has anybody heard of LAMA, the Large Latin American Millimeter Array? Yeah, here we have another radio telescope under construction, but talk about a place full of telescopes. There's Peru, Bolivia, Chile, Argentina. This part of Chile over here is what we're going to talk about next. Ginny.
That's a better name than the very large array.
I agree. I think llama is a much better name. And the logo is adorable. Yeah, I want a stuffed llama with an astronomy logo on its side. That'd be awesome. All right. So has anybody been to Paranal or any other part of the Atacama Desert in Chile? This is one of the most famous places in the world for astronomy. And this is where many, many countries, Japan, who have I not talked about? Vietnam, other countries around the world love to get into international partnerships with the United States and others because we have, back to really boring names, the Very Large Telescope. And over here, the Extremely Large Telescope. We've got another Cherenkov for gamma rays. And here's the thing. There was a private company owned in the United States. It's gone through different names, but now it goes by AES Andes. This is an American-owned company that generates and sells power in Chile, Colombia, Argentina. We want clean energy. We want clean water in South America, don't we? So does it have to be right here where all the telescopes are? Well, the answer in a way is yes, because to get all the equipment to the telescopes, they had to build roads. They had to build facilities like hotels for people to stay in, right? So all of the infrastructure, hospitals, all of the infrastructure is in this area because the astronomers are building all these great telescopes. But it means that's an excellent place to put a data center, which uses a lot of water, or maybe a mine that also uses a lot of water. But look at all the good stuff you'll get out of it. Well, so they submitted their environmental impact study to the government of Chile in December and said, this is what we want to do, and this is where we want to place it. And the European Southern Observatory, who runs a lot of the astronomy facilities we just talked about, said, no, we want you to move it. Just go a little further south, away from our telescopes, away from our dark skies, because we're really concerned not only that you're going to mess things up for the future, but you're definitely going to mess things up during construction. Dust emissions during construction, increased atmospheric turbulence. That means you're stirring up all of that dirt and all of those molecules that we wanted to keep calm. Now you're making them all excited. We don't want that. Light pollution will irreparably impact the capabilities. Irreparably, because once you're making your energy, you're going to keep wanting to do that at nighttime. You don't want to stop just because the sun has set. You're going to run your factory 24/7, which means that light pollution will be 24/7. And, there have been European countries and companies who've already invested lots of money, so please don't mess up our stuff. So obviously this is pending. They're thinking about it. But let me show you in a little more detail where we are. And that is the lithium triangle. Has anybody heard of lithium before? Yeah. Okay, so we're going to need lithium for batteries. The batteries in your cell phones, the batteries in your electric vehicles. Lithium has been used for medical purposes for a long time. There are many, many different uses for lithium. And all of these salt flats, so here we've got a salt flat in Bolivia. This is the one, the Atacama, that's next to all the telescopes. But we've got the Maricuna and one in Argentina. So where are they going to put their stuff? Because no matter where they go, they're getting into somebody else's business. So actually, trying to figure out where to put that clean energy project is tricky. They can't just move it. Or they could, but they'd have to do a lot more planning. And let me point out that planning is what we pay people for. Is that right, Pablo? One could find a solution if one wanted, and maybe the company could build a new road and a new hostel or hospital. Anyway, there are 3 companies that have been doing this work, mining lithium in Chile, right where the telescopes are. They've been there since the 1980s. Some of us are from the 1980s. Oh, is it 8:42? 2 more minutes. Okay. So we've got a Chilean company, a US-based company, and a Chinese company. And the Chinese company is BYD. So if you don't like a Tesla and you want an alternative and you decide you don't want a Rivian, you cannot get BYD in the US yet. But the key word there is yet, because BYD is the #1 most popular Chinese electric vehicle in Europe. Okay, so all 3 have rental contracts with Chile, and they do say there's money set aside for, quote, sustainable development of the communities. Well, in the meantime, let's see what they're doing. This, what you're seeing here, this image, this is a brine pool. Brine, B-R-I-N-E, is salty water. So there are 2 ways you can get lithium. In Australia, they've got rocks full of lithium, so they've just cracked the rocks apart. But for the rest of the world, Chile, come on in, guys. Chile and Argentina, all these places we've been talking about, what you do is you get the salty water up on the surface, you let the water evaporate away. All right. Is there anything outside to see that's solstice? I'm almost done, actually. Okay. Well,
The sun is set, and there are a few clouds over there.
okay. So we will get a chance to go outside in the relative cool, and we're going to look at telescopes in just a few minutes, because I'm almost done. So you let the water evaporate away. What's left behind is the lithium salt, and that's what you want. That's what you're going to process to put into your cell phone batteries. So we need to make some decisions. How do we want to invest? Where do we want to invest? How do we want to spend our money, our time? Which products do we want to buy? From whom? So can we enjoy our dark skies? Can we have financial security? Can we have clean energy? Can we have it all? Yeah, but we got to plan for it, and we have to protect what we value. That means we have to decide what we value. Do we value our dark skies in Berthoud? Then let's do something about that. There are other places that are protecting their dark skies. And as Brian pointed out, there are 6 or 7 places on the official dark sky list for Colorado. So let's put Berthoud on here. Any other comments or questions? Yeah, Ginny.
Can we look at telescopes now?
Yes. Thank you, everyone. Oh, wait.
And one thing that the organization that studies dark sky helps all kinds of good events called the Dark Sky International, and their website is darksky.org. So if anybody wants to follow up on this, that's where you go.
Fantastic. Thank you. Thank you very much.
Stop.